Okay, Jackie, the first thing that I see on your running analysis is where your foot strike is happening. The blue line that you see is a line that's supposed to represent your center of mass. In an ideal running form, your foot is going to strike the ground very close to directly underneath your center of mass. On the right-hand picture, you can see that line. It's drawn roughly through your ear, shoulder, and hip. And you can see that your right foot, when it hits the ground, and you can see it on the left as well, is hitting well ahead of that blue line. So that means that you're not landing under your center of mass. That does a couple of things. One, it's causing a lot of braking forces. So if you're overstriding like that, it means that you're landing on your heel, which is automatically going to stop your forward propulsion. It also means that the foot is not striking the ground in a way that's going to absorb impact forces. So as that heel hits the ground, all those forces are traveling up the leg. For you, that might be what's contributing to the frequent shin pain and shin splints. I actually counted your cadence as well. So if you watch this video and you count the number of steps on one foot, we can then calculate how many steps you're taking in a minute. Ideal running form wants you to be taking 180 steps per minute. From my calculations, you're running anywhere from 172 to 176 steps per minute. So that's something that can definitely be worked on, and something that can improve your running form and decrease your injury risk. Okay, another piece that we're going to look at in this lateral review is the amount of bend that's in your knee at impact. So again, we saw that you appear to be overstriding, so your foot is landing far in front of your body when you're landing, and that's causing a slower cadence and also causing some excessive braking forces throughout the lower leg. The other piece of the landing that can have an impact on the amount of stresses going through your lower body is how much your knee is bent. We want the knee to bend about 140 to 160 degrees when the foot hits the ground, because that's going to allow the bent knee and the quadricep muscle, the muscle on the front of your thigh, to absorb some of that 2 to 3 times your body weight that's landing each time your foot hits the ground. So if we look at the picture on the left, I'm just going to kind of slow-mo through this a little bit. I'm going to go back a little bit, so we're going to watch when that left foot hits the ground. So right there, right about when it hits the ground. That's actually a little bit after it's already hit. Your toe will still be pointing up when it hits the ground, so let's move it back a tad. Okay, so right about there is right when the foot is hitting the ground. So again, let's look at how far the foot is in front of your center of mass. So I'm going to draw a line here, drop it straight down. Okay, so if we call that your center of mass, your foot is quite a ways in front of that center of mass. I'm going to erase those, and now we're going to look at the angle of that quadricep. So we're going to draw an angle here, there, so I'm going to bring it up through your hip, this line right at your knee. We're going to swing this line down right through your ankle. Okay, right about there. Get this guy in here. Oops, let me delete that. Okay, so I've got the angles drawn on the right leg and the left leg here. So as you can see, on the left leg, the angle is about 164 degrees. On the right leg, the angle is roughly 166 degrees. So that's at the very high end. In fact, is over the range that we want for the knee extension or the knee bend at impact. The larger that angle is, the straighter your leg is, which means that your quadricep muscle is absorbing less of those braking forces, less of that stress that's traveling through your lower limb and stressing the joints, the bones, the muscles, etc. Again, potentially leading to injury and potentially a huge contributing factor to the repetitive stress fractures that you're getting in that lower leg. All right, the next thing I'm looking at in this lateral view is the amount of bend at your ankle or your dorsiflexion. The key thing that we want to look at here is how much dorsiflexion you have at mid-stance. So when you can see that your knees are at about an equal place in this picture, your foot is flat on the ground. If you cycle forward a little bit, we're just before the heel rises off the ground so that you can go into that next step. So let's get that back to the angle that we want it. Okay, so just before your foot is about to rise up off the ground, you can see that angle that I've drawn in there on both the left leg and the right leg is at about 66 degrees. So 90 minus 66 is 24 degrees. So that's the ankle angle, the ankle dorsiflexion angle, 24 degrees. Now the ideal place that we want to see this is at 26 to 50 degrees. So again, you have not a lot of bend in the ankle at mid-stance. That lack of ankle mobility means that you don't have as much shock absorption happening through that ankle joint, just like we saw at the knee. That's another contributor to forces being absorbed all the way up through the leg. If our joints can bend and the muscles can contract to accept the load of the foot hitting the ground, you're going to have less vibrational forces traveling up into your foot, into your tibia, into your knees, into your hip. So again, this is another contributor potentially to the problems that you continue to have in your lower leg.